here's your factoring review, and factoring comes from section 5.4. Okay, so the first one, 8x to the 5th minus 18x. Remember, the first thing you should always do with a factoring problem is take out any greatest common factors, any GCFs. So I can take out a 2 for both of those and an x from both of those. So that will leave me with 4x to the 4th minus 9. And then, hopefully you catch that this is the difference between two perfect squares, and it's 4th degree, not 2nd degree. So I'm going to factor that down to 2x squared plus 3 and 2x squared minus 3. And then lastly, you should check, do either of these quadratics factor down? Well, this is the sum of two numbers, and neither are perfect squares, so no. Difference, but not perfect squares, so no. And that is my final factoring. Alright, the second one, can you take something out, a GCF? Yes, you can take a 2 out of everything, so that'll leave you with x to the 4th minus 9x squared minus 10. And then it's just like a quadratic, except it's 4th degree. So what are factors of 10 that add up to 9, or factors of negative 10 that add up to negative 9? So that would be x squared minus 10 and x squared plus 1, because negative 10 plus 1 is negative 9. And then difference, but not of perfect squares, so that doesn't factor down. Sum of two perfect squares, but sums of perfect squares don't factor down. So once again, that one is finished. Okay, the next one, and I hope you're pausing these and trying these on your own, right? I can take out a 2 first, so that will leave me with x cubed minus 27. And then I hope you catch or caught that this is the difference of two perfect cubes. So I'm just going to remind you that you need to have the difference between two perfect cubes and the sum of two perfect cubes. This formula is memorized, so I'm just going to write them up here. So if you have a cubed minus b cubed, that factors down to a minus b. And then it's a squared plus ab plus b squared. Okay, if it's the sum of two perfect cubes, then it's the same a and b pattern, except it's a plus in the first, and then it's a minus ab. Okay, so make sure you have those down. Anyway, this one is the difference, so I'm following this pattern. This is an x cubed, and 27 is 3 cubed, so my a is x and my b is a 3. So you're just plugging in x's and 3's for all of these. So it's going to be x minus 3 for my first one. And then a squared will be x squared plus a times b, so that's 3 times x. And then plus b squared, and so that's 3 squared, which is 9. And then this, if you remember my little reminder in class, this trinomial piece of the perfect square factoring will never ever factor down, but you know that there are no factors of 9 that will add up to 3, so you can certainly double check yourself. So that's it. Okie dokie, last one. Note there are 4 terms. Nothing I can take out of everything, so hopefully 4 terms screams at you. You need to group. So I'm going to group the first 2 together, and I can take out an x squared from the first 2. And remember, the point of grouping is to get this to match this. Well, right now they're completely opposite signs, so why don't you take out a negative 1, which will leave you with a positive x plus 2. And then I'm going to factor out the common binomial piece, so that's going to be factoring out the x plus 2, although the order doesn't matter. And if I factor out the x plus 2, that leaves me with x squared minus 1. And now I have the difference between two perfect squares, so that factors down to x plus 1 and x minus 1. And that's your final answer.